Great. Okay. Thank you. My name is Luke Peterson. I'm a computational physics group leader at Lawrence Livermore Labs. And I believe I was asked to talk about AI workflows because I'm coming at the problem from a user standpoint. One of these scientists is trying to get work done. And through the course of the past few years, I've sort of stumbled into incorporating AI into some of my workflows. So next slide, please. So what do I think an AI workflow is? And at the face of it, I think it's a workflow that has artificial intelligence or machine learning systems as either workflow components, subcomponents, and or orchestrators. And so what I mean by that is, we're having these sort of intelligent workflow systems where they follow this sort of canonical path where they will gather all the data. They will train a model, so a machine learning model, an AI system. They'll then deploy that model, and then they'll use that model to make a decision, and often that decision involves gathering more data. So at the component level, what we have is we've got these systems. They're either training a model, you're building it, or you're deploying it, you're using it to make decisions. Or it could be a subcomponent. You actually can have these AI systems embedded with other software components. And so what I mean by that, you might have a future large high-performance computing code that has a subcomponent to it as an AI system. And I would even consider that to be a workflow, an AI workflow, because you have to coordinate the larger code and the embedded AI system working together. And then finally, you can have AI systems as orchestrators for the workflows, so enabling these sort of intelligent, automatic, and dynamic workflow steering. So to kind of cut through the buzzwords, I figure if it's a workflow and it has AI in it somewhere or a machine learning system, I'll consider that an AI workflow. So next slide, please. So what are some of the challenges with that? And I think fundamentally, I'm going to talk about the context of high performance computing, which I think a lot of us here are, and it's at least my experience. There's a fundamental challenge for these AI HPC workflows, and that's this tension that AI and machine learning systems were born out of industry and an ecosystem that wants many examples of small chunks of data. So you think, millions and millions of samples of images, right? HPC ecosystems and exascale systems, on the other hand, were designed to produce few examples of large data. So very large running codes. You don't run it a million times. You run it, once or twice. You get your Nature paper, and then you call it a day. And so there's this fundamental tension between AI machine learning systems that want lots and lots of little bits of data and HPC ecosystems that are designed to create few examples of large chunks of data. So next, what this means is we have a number of challenges emerge. One, we've got data-driven computing. So the data is actually driving what's going on in the computing. We have heterogeneity in software and hardware. So not only do you have an AI system running alongside an HPC system, but you also might have AI-specific hardware running along traditional HPC-specific hardware. This folds into things like we have distributed, edge, and high-frequency computing. So in AI systems, you might have computing all over the place. You might have edge sensors, for instance. They're sort of loosely coupled or communicated, and they can communicate in very high frequency. Another interesting thing to keep in mind is with AI workflows, the simulation results themselves are not necessarily the product, right? We might be trying to create a model, and it's this model that we're creating that we're ultimately interested in. All the data and the simulations that we're gathering in between are sort of a means to an end. Another thing I kind of touched on is that state of the practice for AI and ML is not focused on HPC. It's focused on being able to run on your phone, being able to post Instagram posts, be able to predict which Netflix you want to stream next. And a lot of these are being driven by industry, and so they're very fast-paced developments. So how can we as a community leverage these fast-paced developments that are driven by industry for very other applications, and they aren't being driven by science? Next slide, please. So in my mind, if you were to write down some requirements for AI systems, AI workflows, they really need to be able to, at the top level, handle very large volumes and high throughput of data. So the entry level is sort of 100,000 simulations. And each of these can produce lots of data. They also need to be able to coordinate different hardware being used both in and across workflow steps. So we have the coordination of CPUs, we have the coordination of GPUs, we have the coordination of tensor processing units, TPUs, and coming down the road in the next few years, we have these more specialized ASICs application on specific integrated circuits. So things that are designed just to do AI components. And so coordinating that different hardware that might be on different machines or different parts of machines is going to be a challenge. Also, these workflows definitely need to allow for dynamic branching and online decision making, because if you're having an AI orchestrator moving things around, it's going to want to make decisions on the fly. But how does that fold into provenance? How can we enable this automation but retain the provenance and ultimately have a system that is explainable? The big thing about AI now is, okay, you have an answer, but can you explain how it got to it? Okay, you managed to orchestrate this long sequence of workflow steps, but why was that decision made? Can you go back afterwards and figure it out? So those are my challenges that I saw. I'm interested to hear what else the community is thinking about. AI is a big buzzword, and this is an opportunity to kind of put some nomenclature around it and kind of get a handle about some of the challenges and steps going forward. So I believe that's my last slide.